Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Alright, so welcome back, welcome to Testbook.com Gate channel. So, Bida, in the last session, what we have completed in the last session, we have started with the simple mechanism, right? We have started in the last session with the simple mechanism. Now, in today's session, Bida, we are going to talk further about the simple mechanism. ठीक है, हम आज के सेशन में simple mechanism में further बात करेंगे, okay? So now we are going to talk about the simple mechanism furthermore, right? So, Bida, in today's session, up to the last session, we have seen what were the links, what were the type of links, and what is required of a mechanism. So, in this session, Bida, the first thing that I want to ask you that in the last session, we have defined a link. Is it or isn't it, Bida? We have defined the link in the last session. We have defined the kinematic link in the last session. We have seen it is something which is having a relative motion with respect to other parts of the machine. So I told you in the last session, beta, where we ended. So we ended at the relative motion. So what are the type of relative motion? What are the types of relative motion? I hope that all of us know what is relative motion. Now I want to ask you the types of relative motion. So those who are live here can please reply to me. जो भी लोग live है बेटा please reply करिएगा, ठीक है? Please reply करिएगा. Okay, so what are the types of relative motion? क्या type के relative motion होते हैं? What types of relative motion are there? So I hope all of us understand the meaning of relative motion. When some body is in motion with respect to any other body, that is called as relative motion. Now what are the type of relative motion? Relative motion के क्या types होते हैं? Can you please tell me? Those who are live beta can respond to me. So the type of relative motion with us are completely constrained motion, right? Completely constrained motion. So before that, I would say, so let's say firstly, so if we broadly classify the type of relative motion, so first of all, it can be broadly classified in constrained motion and unconstrained motion. These are the two types of motion, unconstrained motion. Now I want to ask you something. Now I want to ask you this. So what are the types of further constrained motion? Constraint means what? What do you mean by constraint? Constraint का क्या मतलब होता है? What do you mean by constraint, my dear? So constraint is something which is restricted. So these two are the broad type of relative motion. ये broadly हमारे दो type of relative motion होते हैं. Now what do you mean by the constraint motion? What do you mean by constraint motion? So we will be approaching through questions, बेटा, ठीक है? हम थोड़ा क्वेश्चन के साथ अप्रोच करेंगे. We'll be approaching with the questions. So what are the types of constraint motion? So constraint motion are those. So in the last session, beta, I told you something that this is something which is most desired for unique input if we get unique output, right? So this was our desirability. This was the most best thing that can happen with us, right or wrong, beta? So in the last session I told you particularly that this is what we require. This unique output was the necessity. Unique output एक necessity है और unique input desirability है. But ये मिल जाए तो सबसे अच्छा है, right? This is the best thing what we can get. So this is what we mean by constrained motion. Now further, this constrained motion can be classified as completely constrained or successfully constrained. So the two types of constrained motions are completely constrained motion. So this is CM. CM means constrained motion. successfully constrained motion. Now my question to you is, input was not the necessity, it was desirability. But if we get, Vishnu, if we get unique input to unique output, that is the best thing we could get, no? Remember, if we are getting unique input and unique output, this is the best thing, and that is what we know as constrained motion. Okay, so in theory of machine, we will try to make the motions constrained, because we established in the last session that though unique output is the necessity, but unique input is the desirability. So the best proposition that we can get from a system is that we give a unique input and we get a unique output. Agreed to it or not, my dear? Agreed to it? So I hope you agree to it. Now, constrained motion are of two types: completely constrained and successfully constrained. Right? Now, what do you mean by constrained? What do you mean by constrained? So constrained means, what is the meaning of this constraint? So constraint means restricted. Now, if we restrict some motion, if we restrict some motion, if we restrict some motion, if we restrict some motion in a way, if we restrict some motion in a way, if we restrict some motion in a way that it has always happened in a particular manner. It always happened in a particular manner. For example, I gave you in the last session the piston and cylinder arrangement. Did I or didn't I? Did I or didn't I? So yes, sir, you have given us that. You have given us that piston cylinder arrangement. So somewhat this, isn't it, beta? Isn't it? Yes or no? Now in this, what we established in the last session, that piston always reciprocate. Piston always reciprocate in the cylinder. Connecting rod always oscillate and crank always rotate. Right, my dear? Right? Right. Now, can we say the motion of the piston, the motion of the connecting rod, the motion of the crank is constrained motion? How we can say so, sir? How we can say so? How we can say so? Because the motion of the piston is always constrained, that is means restricted to reciprocate inside the cylinder. Similarly, the motion of connecting rod is always restricted, crank or flywheel, because flywheel is mounted on the crank, my dear. So kinematically, they do not have any difference. What we learned in the last session, beta. What we learned in the last session. So any two things which have no difference in motion can be called upon as the same link, no? So crank and flywheel are mounted on the same shaft. They rotate at the same speed. So when they rotate at the same speed in this and the same direction, is kinematically any difference between them? Are they different link or the same link, Vishnu? Are they different link or the same link, Vishnu? So obviously they are same link. Obviously they are same link, right? Obviously they are same link. Okay? Okay, now my question to you is, and everyone is, what are the so can we say the motion of the piston, connecting rod and crank is constrained? Say yes or no. Individually, is the motion individually is constrained? Yes or no? And also, please listen to me very, very carefully. It's a beautiful subject. Now, as a whole, as a system, as a whole, this arrangement has again motion as constraint, right, beta? Right? How, sir, you are saying? Because always in this we are getting unique input to unique output. Unique input to unique output. Right or wrong, my dear? Always in this we are getting unique input to unique output. How, sir? How, sir? Because always when we give input in the cylinder, when we burn some gas in the cylinder, it due to its pressure, piston reciprocates and it makes cranks rotate. So always in this, the reciprocation of the piston changes to the reciprocation of the piston changes to the rotation of the crank. So this whole system, we can say, we get always for unique input, we get unique output. Unique input, then we get unique output. Unique input to unique output. I misspelled it there. I write it wrongly. So this is unique input to unique output. I hope it is fine to you. I hope it is fine to you. Now question is, my question to you is, what is completely constrained motion? What is completely constrained motion? What is completely constrained motion? So as I said, we'll be approaching with questions now in the YouTube sessions. Okay, so we can have a go through with that. Bataiye, what is the completely constrained motion? What is the completely constrained motion? Can you answer me this? Can you answer me this? I am waiting for the replies of the live students. Please go for it. And meanwhile, while you are replying it, also like and subscribe the channel. Testbook.com Gate channel. So many subjects are going here for free. Alright. So do not forget to like, subscribe, also share with your friends, also share at your social media platforms. So because the number of students, higher the number of students will come here, higher will be the motivation of ours, higher will be the quantum of questions that we are going to discuss, higher will be the concept. So what is completely constrained motion? What is completely constrained motion? So my dear, completely constrained motion, listen to me, completely constrained motion is the one, completely constrained motion is the one, completely constrained motion is the one, completely constrained motion, my dear, is the one, for example, this completely constrained motion is the one in which, my dear, the motion between the links is constrained by itself. Means, now if the motion, now we know constrained motion, now what does this completely means? What does this completely term means? What does this completely term mean? So if by itself, if the motion is constrained, constrained by itself. Now what do you mean by itself? Means without any external intervention, without any external means. My dear Vishnu, you are saying input to output. No, beta. Constrained motion means that for unique input we are getting unique output. So constrained motion, either it is successfully, completely, both will have the same meaning. Now when we are seeing obviously when we are seeing between completely and successfully, so we need to point out the difference between them. We need to point out the difference between them, that what is the completely constrained motion and what is the successfully constrained motion. We need to point the difference out of it. Understood my point, beta? Understood my point? We need to point out the difference. So what is the difference? Constrained motion is something, either it is successfully or completely. That means for unique input we are getting unique output. But if we are getting the same by itself without any external intervention, that means the motion is completely constrained, right? Like this, as you can see here, So if I say in this, so see, this subject, no, same area, Nissan, my dear. So in this subject, beta, we have to have some imagination, because we are reading it in 3 dimension. We are reading it in 2 dimension, but we have to visualize the thing in 3 dimension. So please see. So we need to see. Sir, why not you directly give us 3D figure? Because in the examination also they are not going to help you in that way, beta. They are not going to help you in that. Okay. Now you have to understand seeing the 2D images, and you need to interpret it in 3 dimension. You need to have it interpreted in 3 dimension. Now if I see this figure, so we have a block which is hashed, and it is having a square hole, and there is a square bar inside it. Now if I give a particular kind of input in it, it can only reciprocate. Now this square bar can only reciprocate. Now do you agree to me or not that, sir, yes sir, it can only reciprocate inside this hole? Yes or no? Yes or no? No, area has nothing to do, my dear. Area has nothing to do here. It is about motion. So from the image itself, you can see that the whole and this having the same sort of dimensions, right? Now you tell me, can you do any other motion of this square bar in this square hole other than reciprocation? Nisa, can you tell me, my dear? Can you tell me? Right? No, sir, we cannot do it. We cannot do it. We cannot do it. Now, I tell you one thing very frankly. Now, sometimes what happens, students are unable to get this. Sir, how a square, sir, why not it rotates? So, I think you have to imagine it. Now, how a square bar can rotate in a square hole or of equal dimension? It is not possible. So I am considering all of you watching this video as very smart to understand it. Right? Now I want to ask you one more question. Now, do you think there is any external factor due to which this constraint happening here? Now, can I use this word? क्या मैं ऐसा कह सकता हूँ? Can I use this word that now this square bar is constrained, restricted, bound to reciprocate only in the square hole? It is bound to reciprocate only, it is constrained to reciprocate only, it is restricted to reciprocate only. हिंदी में बोलूँ तो ये बाध्य है, ये एक तरीके से विवश है कि ये स्क्वायर बार इस स्क्वायर होल के अंदर सिर्फ रेसिप्रोकेट कर सकती है. अब मैं आपसे पूछना चाहता हूँ, नाउ आई वांट टू आस्क यू, नाउ डू यू थिंक एनी अदर एक्सटर्नल फैक्टर इज इन्वॉल्व्ड हियर? Any other external factor is involved here due to which any other external factor is involved here due to which it is having a constrained motion? Can you please tell me any other external factor involved which is making it constrained? Please answer me. Please answer me. Please answer me. Please answer me. A square hole is not making any motion, beta. A square hole is not making any motion, my dear. Only the bar is making a motion. Getting my point? Only bar is making the motion. केवल बार मोशन कर रहा है माय डियर. ओनली बार इज हैविंग द मोशन. स्क्वायर होल इज हैविंग नो मोशन. So if you are not able to understand it, so I will do this. Now this is the image I pasted in 3D. Now you please tell me, my dear, Vishnu, now what do you feel this square bar is doing inside the hole? It can reciprocate only, right? It can reciprocate only. Alright. Now, as I said, as Nisar is answering me, now there is no external aid, there is no external intervention. So, can we say due to the nature of the bodies themselves, it is bounded to have, due to the bodies themselves, it is bounded to have the unique motion, that is constrained motion. So it falls in the category of completely constrained motion. Now, is it understood or not? Please answer me. Is it understood to you guys or not? Can you please answer me that? Is it understood to you guys or not? Can you please answer me that? Is it understood? Can you please answer me that? बताइए. Is it understood? Can you please answer me that? बताइए. Please answer me. Okay. Now I want to ask you one more question. So now you need to identify this. Is it a constrained motion or an unconstrained motion? Please identify it. First of all, please identify it. It is a constrained or unconstrained motion. Is it a constrained or unconstrained motion? Please identify me that. Is it a constrained motion or unconstrained motion? Please identify it for me. Constrained motion or a unconstrained motion? Right, we need not to read this. Chalo. Please answer me. Is it constrained or unconstrained? You have to imagine, my dear. So many questions are getting asked in so many examinations, including GATE. So sometimes they may ask you 1 marks theory questions. So please tell me. Please tell me about it. Please tell me about it. Nisa, you are saying it is unconstrained. You are saying it is unconstrained. Now, can you tell me, Beta, why you are saying so? Why you are saying so? It is unconstrained because I can see or I can feel that it can only rotate in this. It can only rotate in this. Sir, why it can only rotate in this? Why it can only rotate in this? So you understand what is collar. So collar is like this. So you see, so I am making it in another view. So this is your collar. This is your collar, and you see in this small hole there is a shaft. Now, what I am trying to do, see, I can give you, my dear, I can give you three-dimensional figures. That will make you understand the things easily. But that I was saying, that GATE is not going to be so merciful on you. They will be giving this kind of a figure. So you must learn, my dear, to understand from two-dimensional figure. Okay, that is why, my dear, I do not prefer to use animations while teaching theory of machine. क्योंकि गेट के पेपर में in the examination they are not giving you any animation, so you need to train your mind to understand the two-dimensional figure. Now if we see it from the front, this is a two-dimensional figure. So the collar means like this. So collar means like this. This is a plate, a hollow plate on which shaft is mounted, and this hollow plate is placed here, and this hollow plate is placed here. Getting my point, beta? Getting my point? Now on both side we have this hollow plate fixed. We have this hollow plate fixed. So will it be able to reciprocate? Will it be able to reciprocate? Please answer me. Will it be able to reciprocate? बताइए, will it be able to reciprocate? You imagine that. So if you see this is the shaft. If you see this is the shaft, and we have two circular plates mounted over it on both the ends. Now it will this place mounted, these plates which are mounted, these plates which are mounted on the ends of the shaft, will let it reciprocate? Will it let it reciprocate? I don't think so. What do you say? What do you say, my dear? No. Now it is bound to reciprocate only. It is bound to reciprocate only. So this is definitely constrained motion. This is definitely constrained motion. Now I want to ask you, is it completely constrained or incompletely constrained? Is it completely constrained? Yes, Harshal, it is not that. So it is completely constrained or incompletely constrained. See, beta, we need to learn the things. We need to learn the things from. We need to learn the things from. We need to learn the things from two-dimensional orientations, right? Right. So this is definitely a constrained motion. Now I want to ask you, is it a successfully constrained motion or completely constrained motion? Please tell me. So completely constrained motion, what was the completely constrained motion? So it is completed by itself. It is constrained by itself. By itself. Right? So now can you tell me, is it completely or successfully? So definitely sir, this is completely constrained motion because we cannot see any external aid. We cannot see any external force implemented here. We cannot see any external force implemented here, right or wrong, beta? We cannot see any external force implemented here, right or wrong, beta? Right or wrong? Definitely right, sir. Definitely right. We cannot see any other external means which is helping it to make the motion constrained. So definitely it is completely constrained motion. Now, the next question of mine to you is, what is successfully constrained motion? Please answer me. Now we understood the completely constrained motion. So what is successfully constrained motion? What is successfully constrained motion? Can you answer me that? Can you answer me that? All the students who are like, can you answer me that, beta? What is successfully constrained motion? So now the keyword is successfully. Now the motion has to be constrained, it has to be restricted, it has to be bounded. मोशन को रिस्ट्रिक्ट होना है, बाउंड होना है, कंस्ट्रेंट होना है, एक प्रकार का ही होना है. तो कंप्लीटली का मतलब क्या था? व्हाट वी मेंट बाय कंप्लीटली? Completely meant by itself. So successfully meant not by itself, but by some external force, or we can say external aid. So with external help, हाँ सत्येंद्र बेटा, आर एस कुलमी का ही फिगर है दोस्त, ठीक है? आर एस कुलमी का ही फिगर है. ओके, सो फॉर टीचिंग यू गाइज आई रिफर आर एस कुलमी एंड एस एस रतन. ठीक है दोस्त? हाँ चलो, व्हाट इज सक्सेसफुली कंस्ट्रेन्ड मोशन बताइए. हाँ, मेक इट कंस्ट्रेन्ड बाय एक्सटर्नल फोर्स, राइट हर्षल? Okay, so now I want to ask you, so let's say we have a system like this, we have something like this. Please try to see the things in 3D, but they will be given to you in 2D. Theory of machine is a beautiful subject. So we have a shaft inside it. We have a shaft inside it. Now if I rotate it, so I want to ask you, is it completely constrained or incompletely constrained? Can you answer me that, beta? Satyen, Nisar, Harshal, Vishnu, all the live students, can you answer me that, my dear? Can you answer me that? Can you answer me that, beta? So we are making it rotate. We are rotating it. We have given. So this is our input actually. You will say this is the input we have given. This is the input we have given. This is the form of torque or input we have given. Now please tell me, is it a constrained motion or unconstrained motion? This is my first question to you. Is it a constrained motion or inconstrained motion or incompletely? Sometimes they call it incompletely constrained motion also. Sometimes they call it incompletely constrained motion. Chalo, tell me my dear, tell me, is it constrained motion or not? Is it constrained motion or not? What do you say? What do you say? What do you say? What do you say? So now beta, please be careful, please be careful. So it is unconstrained motion, my dear. It is in this condition, it is unconstrained, it is unconstrained, it is unconstrained, it is unconstrained. Why it is unconstrained, my dear? Why it is unconstrained, my dear? Because now please, if somebody is having confusion in it, please do one thing. So I hope you are holding the pen. So just put your pen, just fix your pen like this, just hold your pen like this in your hand and rotate it and hold it tightly, hold it tightly with full of your energy and try to rotate it, try to rotate it, try to rotate it. Definitely it is going to come out. कभी कभी पेन में जब हम पेन यूज करते हैं तो उसके पीछे हम उसका कैप लगा देते हैं, लगाते हैं कि नहीं लगाते हैं? बताइए। पेन यूज करते करते उसके पीछे उसका कैप फिट कर देते हैं, फिर कई बार वो निकलता नहीं है, फिर हम एकदम घुमाते हैं, घुमा घुमा के निकालते हैं। बोलो करते हैं कि नहीं करते? डू वी डू समथिंग लाइक दैट और नॉट? से यस और नो? हेलो रवि माय डियर, हेलो, बोलिए। So when we are holding the pen like this, very tight, we can hold it in our hand. And if we rotate it, definitely it will reciprocate also. So if in a circular hole, a circular body is being rotated, it will reciprocate also. So you are having two motions at output, rotation and reciprocation both. So it is unconstrained motion because we are not getting unique output from unique input. Right? Right, beta? Say yes or no. Do we agree to it or not? Please answer me that. Please answer me. Do we agree to it or not? Please answer me, my dear. Please answer me, my dear. Do we agree to it or not? Do we agree to it or not? Do we agree to me or not? Please answer me that, beta. Please answer me. Please answer me. Now, if I make it like this, my dear, if I make it like this, now please observe, if I make it like this, if I make it like this, now if I apply a load over the top, so if I put a force, if I use a heavy force on the top, now this force, unless external force is applied, can we write like this? Unless external force is applied. So unless external force is applied means from the top, if you apply the force like this, now can we say, my dear, due to this force, the reciprocation is now destroyed. It cannot reciprocate anymore. This reciprocation is destroyed due to this force. So when this heavy force or this load is applied on the top of this shaft, this becomes something useful, and that becomes footstep bearing. Getting my point, beta? And this is the soul of the subject. Now, please understand this. In this subject, beta, we need to destroy the freedoms. हमें रिस्ट्रिक्शन लगाना है, आजादी नहीं देनी है, हमें आजादी छीननी है। जैसे कोई बोले हमें चाहिए आजादी, अरे नहीं भाई, आजादी छीन लेने का। यहाँ पे समझ रहे हो बात को? ठीक है, यहाँ पे जितनी आजादी कम रहेगी, lesser the freedom of a body, more will be the success. Now this is the soul of the subject, let me tell you. So here in this figure, it was unconstrained, having no use or least use because it was having two outputs. So in the last session, beta, I established this fact. If something having no unique output, it is of no use. Now to make some use out of it, we restricted it. We applied a restriction over the top. And now it has become something useful and known as footstep bearing. So this is the general representation of a footstep bearing. Very, very useful. Very, very useful. It is being used a number of times. Right, beta? Right now I want to ask you something more. So sir, have we ever seen this photo? Have we ever seen this image or photo or this system? Can you answer me what it is called? What it is called? What it is called? Can you answer me please? All the live students, my dear, please answer. What is this called? क्या कहते हैं भाई इसको? What is this called, my dear? What is this called, my dear? What is this called, my dear? Please answer. क्या कहते हैं इसको? What is this called? So, sir, now when I see this figure, something is coming in my mind. It is a cam and follower. But I tell you, it is not a cam and follower unless you put a spring here. Getting my point, beta? Why not, sir? Why not? Why not? So unless we put a spring here, it is no cam and follower, because without a spring, my dear, without a spring, when you give input to it, it output wouldn't be constrained. Now, I want to ask you something. Can this follower, so this is the cam, what we say, it always rotate. This is the follower, let me say, and this is the guide. Now, in this guide, it will be successful, it will be a successful thing, it will be a successful mechanism only when there is a spring there. Without the spring, will this cam and follower be able to be having a constrained motion, a restricted motion? Say yes or no. Please answer me. Now, can this follower maintain this reciprocation, this to and fro reciprocation, without the spring being putting some force on it? Say yes or no. Say yes or no. So this is the example of successfully constrained motion. Isn't it, Bida? Successfully constrained motion. This is the example of successfully constrained motion. Right? Right. Right, my dear. Right, my dear. What do you say? What do you say, Bida? Can you answer me that, Bida? बताइए, आंसर करिए. Can you answer it? Is it okay or not? Please say yes or no. Is it okay or not? Please say yes or no to me. Is it okay or not? Please say yes or no to me. Are we able to understand it, beta? Are we able to understand it? Are we able to understand it? Right. Now I want to ask you something. Now I want to ask you this. Now I want to ask you something more. So I want to ask you something more. Alright, so can you answer me, is this constrained, unconstrained, or what? Is it constrained, unconstrained, or what? Can you answer me that, beta? Can you answer me that? Is it constrained, unconstrained, or what? Can you answer me this? क्या आप आंसर दे सकते हैं बेटा? Is it constrained, unconstrained, or what? क्या ये constraint है, unconstrained है? क्या ये constraint है, unconstrained है? Is it constrained, unconstrained? Please answer. Please answer. Please answer. So, sir, in this, so what is unconstrained motion or incomplete constrained motion? Unconstrained, or we can say incomplete constrained motion. So, so what is constrained in constrained motion? What is in unconstrained or incompletely constrained motion? What is unconstrained or incompletely constrained motion? So if for unique output we require more than, so we can write it like this. So for unique output, For unique input, we get more than one output. We can more than one output. So this is a circular shaft. This is a circular shaft in a circular hole. So if you rotate it, my dear, if you rotate it, so it will reciprocate as well. If you give this kind of an input, this will reciprocate as well, right or not? So we are getting two different motions at the output. So can we say it is constrained? No, it is not constrained because we are getting two motion. One is rotation, one is reciprocation. So this is what we call as unconstrained or incompletely constrained motion. So I hope till this point, I hope, please reply me in the chat. I hope till this point, how to identify the completely incompletely constrained motion, the completely incompletely constrained motion, the completely incompletely constrained motion. It is clear to all of you. It is clear to all of you. I think it is fine to all of you. Is it fine or not? Please say yes or no. Is it fine or not? Please say yes or no in the chat. Alright. Alright. So this is what we had for relative motion. Now we have seen the links. Now we have seen the links. Now we have seen the links. Now we have seen the type of links, we have seen the relative motion, we have seen the type of relative motion, and we discussed the examples that can be asked in the examination. What is completely constrained, what is successfully constrained, what is this, what is that. Understood, beta? Understood or not, beta? Okay, understood or not? Okay, so I hope it is understood to all of you. I hope it is understood to all of you. Now, moving ahead, my dear. Now, moving ahead, my dear. So, in this beta, in this, we are now further going to talk about pairs. So, we have spoken about the links. Now, alone a link can do nothing. So, we need to form a pair. Now, my question to you is, so what is a kinematic pair? Now, what is a kinematic pair? So, we have seen the links. Now we are going to talk about the pairs. So what is kinematic pair? So if I ask you what is kinematic pair, can you answer me that, beta? If I ask you what is kinematic pair, can you answer me that? So now I will say, so my dear, when we say pair, so please listen to me carefully. When we say pair, so any two links may be joined. No matter by how means they join, they will always form a pair. So something when two things are getting connected, they always form a pair. We know that, right? हमें ये बात पता है कि when we connect any two things, they will form a pair, right? But for that pair to the kinematic pair, for that pair to be called upon as a kinematic pair, the motion between the links must be constrained. So I'll give you a tip here. मैं आपको एक tip भी देता हूँ. I'll give you a tip here. So whenever you see this word kinematic, just understand that when the motion becomes constrained, we'll use this word kinematic, right? Kinematic. Okay, so the motion between the links agar constrained hai, if the motion between the links get constrained, that's what we call as kinematic pair. So now, if two links are connected in a way, for example, we have, let's say, a cylinder, we got a cylinder here, and we place a piston inside. We place the piston inside, and this piston now can we see that it can only reciprocate inside the cylinder. So when it is only reciprocating inside the cylinder, always it is doing the same thing. So can we say always it is doing the same thing? So can we say can we say the motion is constrained and hence it is a kinematic pair. It is an example of a kinematic pair where a cylinder, where a piston is reciprocating inside the cylinder. So always the piston does reciprocation inside the cylinder. So the motion is always constrained in this. So this is a kinematic pair. Now the question is, what are the types of kinematic pair? What are the types of kinematic pairs? क्या types होते हैं kinematic pairs के? What are the types of kinematic pair? Can you answer me that, beta? Can you answer me what are the types of kinematic pair? Okay, so sir, kinematic pair can be classified in how many ways? Or this is the one part of this question, or we can quote another question here. In how many ways? In how many ways kinematic pairs may be classified? In what different ways a kinematic pair may get classified? Okay, in how many ways a kinematic pair can be classified? Okay, okay. So what are the answer to this question? What are the answer to this question? Can anybody try to tell me, Vida? The live students. I am hoping that we read theory of machine, we have some information about it. So in how many ways kinematic pairs may be classified? So kinematic pairs may be classified in three ways. Okay, according to the type of relative motion between the links, obviously. According to the type of relative motion, getting my point with that? One way can be according to the type of relative motion. Another way can be according to the nature of contact and according to the type of closure. According to the type of closure. Getting my point? Getting my point. Now, if I ask you, what are now further question that may arise from here, that what are the types of kinematic pair that come under the type of relative motion? Relative motion के type के according किस type के kinematic pairs होते हैं? Now, according to the type of relative motion. Now, according to the type of relative motion. According to the type of relative motion. Now please understand this. Very, very important, very, very useful. Okay, so according to the type of relative motion, what can be? So the first one is turning or revolute pair. Turning or revolute pair. Now, if I say turning or revolute pair, so that means, so if there are two links and they are connected by means of a pin like this, so that one link can only make turn or revolution or rotation or oscillation with respect to the other one. Getting my point, beta? So if two links are connected using this pin joint, they forms a turning pair, right? They forms a turning pair. Getting my point, beta? Or we can say if some link is rotating with respect to the other link, if some link is rotating with respect to the other link, okay? With respect to the other link, they form a turning or revolving pair. Revolving pair. Getting my point, beta? Getting my point like this. Okay, when there is a pin joint like this, with collars, obviously. Okay, so this is the example of turning pair. This is the example of turning pair, right? Now I want to ask you something. So if I am saying like this, if two links are joined like this, now is it a, my question is it a, so when there is a pin join between them, is it a point contact or surface contact? Can you answer me this, beta? Is it a point contact or surface contact? Can you answer me that, my dear? Can you answer me that? Is it a point contact or a surface contact? Please answer me. Is it a point contact or surface contact? Can you answer me that? Can you answer me that? Please answer me. I am waiting for your answer. I am waiting for your answer. Please answer me. Please answer me, my dear. Please answer me. Please answer me. Is it a point contact or surface contact? Now, some of you might be thinking, sir, sir, this is a point contact. Some of you might be thinking this is the point contact. So, why people say it's a point contact? Because they see a point here. So, no, my dear, this is surface contact. Sir, how you are saying this? Sir, how you are saying this? How you are saying this? Sir, how you can say this? How you can say this, sir? How you can say this, sir? How we can say this, sir? How we can say this, sir? So, sir, I ask you now, please see. I ask you, beta. Now, I ask you for one thing. If you remember, I ask you for one thing. My dear. I ask you for one thing to see whatever is there in 2 dimension, you have to see it in 3 dimensions. So when I see this connecting rod, so now what will I do? Now please understand this. So we have been making this figure again and again. Just want to ask you something. I say this is connecting rod. Now, this is the connecting rod represented in 2 dimensions. This is the connecting rod, my dear, represented in 2 dimensions. The actual connecting rod is like this. In actual, the connecting rod is like this. Please tell me, in actual, the connecting rod is like this or what? If we Google the image of connecting rod, Divyanshu, if we Google the image of connecting rod, you can Google it right now. If you Google the image of connecting rod, so what you are going to get. So I'll just show you here. So if you Google the image of connecting rod, you are getting something like this. Now you see if I say to you, yes, eventually it is surface contact. So if I say to you that we get to make the joint, we want to make the pin joint. Now, is it understandable that you will get some sort of this again? You will get some sort of connecting rod again. And you are going to place it. So you are going to twist it like this. And you are going to bring it upon over this face. So just I am trying to show you this. So this is the connecting rod. When you are going to connect it to another link, you are going to place all 2 equal sizes hole on here. And then what you will do? You will put a pin of this big. exactly of that size of this, exactly of the size of this hole, right, exactly of the size of the hole, and you make the pin joint. So when we say pin joint, is it a point contact? Now if you relate it, that is why I keep telling you in this session, that is why putting I am putting the weight on it. इसी बात इसीलिए मैं इस बात पे बार बार जोर डाल रहा हूँ, इसीलिए मैं इस बात पे बार बार जोर डाल रहा हूँ कि भैया हमें दिखेगा 2 डायमेंशन, लेकिन हमें करना है 3 डायमेंशन में. दैट वी हैव टू सी थिंग्स आर देयर इन 2 डायमेंशन, थिंग्स विल बी गिवन इन 2 डायमेंशन, बट वी नीड टू सी देम इन 3 डायमेंशन. हमें उन्हें 3 डायमेंशन में देखना है. Now if we say when we are putting the joint like this, we are connecting the two links like this, so we are having the links like this, we are having the links like this, and we are connecting them. So when we are connecting them, we are following, we are making the hole over there. On that hole we are putting like this. Now I think it is very very understandable. Now I think it is very very clear to all of you that this is certainly a surface contact. So what happens when we see this point? We think that a point is there, so it must be point contact, but it is no point contact, it is surface contact. So your turning pair makes a surface contact. Now the second type is sliding pair. Now the second type is sliding pair. The second type is sliding pair. So now very obviously, so if we have a cylinder like this, if we have a cylinder like this, if we have the cylinder like this and we have a piston like this, we have a piston like this, we have a piston like this, definitely this piston is sliding inside, is sliding inside, is sliding inside the cylinder, is sliding inside the cylinder. So if I say there is some link like this and some another link is sliding or reciprocating over it, now the pair between them is what? Is a sliding pair. So obviously, my dear, obviously, sliding pair. So it is this kind of classification is because of this kind of classification. ये classification है motion के according. So if between two links the relative motion is of sliding kind, so that is we call it a sliding pair. Now I want to ask you, what kind of contact is there? What is the kind of contact will be there? What kind of contact will be there? Can you answer me that? What kind of contact will be there? So definitely, sir, if we see it in 3 dimension, that is the focus of today's session, beta. Seeing the things in 3 dimensions. Okay, so if this is the diagram, so if I see it in 3 dimension, so your slider will go like this, and this is your surface. This is your surface, whole of the surface. Getting my point or not? Getting my point. So definitely, sir, this is the surface contact. Definitely, sir, this is the surface contact, isn't it, beta? Isn't it? So again, surface contact, right or wrong, beta? Again, surface contact. So when there is a surface contact, when a sliding pair happens, there is again the surface contact. Is it okay or not? Please answer me that, beta. Is it okay or not? Is it okay or not? I hope it is okay to all of you. I hope it is okay to all of you. Is it okay or not? Please answer me. Is it okay or not? Please answer me, my dear. Please answer me, my dear. Is it okay or not? Is it okay or not? Please answer me. Please answer me. Please answer me. Right? Right. Now moving to the next one. Yeah, Divyanshu. So moving to the next one. So we have this sliding pair. Now the next one is the rolling pair. The next one is the rolling pair. Now, as the name suggests, if a link rolls with respect to the other one, getting my point? So if the links obviously, so what is a rolling pair? What is the rolling pair? What is the rolling pair? So if the links have So need not to write it. So definitely, as the name suggests, if the links are having relative motion of rolling between them, relative motion of rolling between them, as there happens in ball and roller bearing. This is the example of rolling pairs, ball and roller bearing, ball and roller bearing. So that will be called as the rolling pair. That will be called as the rolling pair. Getting my point, beta? Getting my point. Now remember, when we say rolling, so we are referring to pure rolling. We are referring to pure rolling. So what is this pure rolling? Pure rolling is the rolling without any slip. It is the rolling without a slip, without a slip. So that is your rolling pair. That constitutes a rolling pair. Now, when you know, so when something is having in pure rolling, something is rolling about the other, the kind of contact is there, is line contact or point contact. So we can say in rolling pair, point or line contact is formed. Point or line contact is formed. So I hope it is fine to all of you, right? I hope it is fine to all of you. I hope it is fine to all of you, right? Okay. So rolling pair में क्या होता है, my dear? Rolling pair में क्या होता है? Rolling pair में क्या होता है? Rolling pair में क्या होता है? रोलिंग पेयर में हमारा पॉइंट कांटेक्ट या लाइन कांटेक्ट होता है. नाउ द नेक्स्ट वन, अकॉर्डिंग टू द टाइप ऑफ मोशन, सो स्क्रू and nut pair. The next one is screw and the nut pair. Getting my point, beta? The next one is screw and nut pair, or sometimes can be called as screw pair only. Screw pair only. Getting my point, beta? ठीक है, ठीक है, ठीक है. So like for example, lead screw of the nut. Now, do we agree to this that, sir, a screw have the kind of a motion which is not really pure rotation, which is not really pure reciprocation, but it is a combination of both, isn't it? All of us have seen screw and nut, isn't it? क्यों दिव्यांशु? हम सब ने नट एंड स्क्रू वाला हिसाब किताब देखा है. Lead screw of the nut, lead screw of the lathe, sorry. So हम सब ने, I hope हम सब ने बेटा देखा है नट बोल्ट, है ना? Now when I see the motion of a screw, can we say it is not completely, it is not purely rotation, neither it is purely reciprocation, but it is a combination of both of them. ये दोनों का combination होता है, right or wrong? ये दोनों का combination होता है. Is it combination of both of them? Yes or no? So I think yes only, no? Right? In one rotation, the distance traveled by the screw is equal to its pitches, है ना? है ना? So कभी भी screw pair होगा. So for example, lead screw of lathe. So now I want to ask you again: is it a point contact or the surface contact? So definitely, it is going to form a surface contact, right? Right. So what kind of a contact between a nut and bolt is there? बोलिए किस टाइप का कांटेक्ट रहता है? So obviously, sir, the type of contact there is surface contact, right? Right. Yes or no? Do we agree to it? I hope we agree to it. Now moving ahead with this. Now the last one is spherical pair. Now according to the relative motion, the pair can also be classified as the spherical pair. The pair can also be classified as the spherical pair. Getting my point, beta? For example, ball and socket joint. For example, ball and socket joint. Okay. So in our body, we have ball and socket joints there, right? So if you see my hand, so I can move like this, 3-dimension rotation. So spherical pair means so if a link can have 3D rotation with respect to, if the link can do 3D rotation with respect to the other link, it is what we call as a spherical pair. So in God have given us the spherical pair in our body. This is a spherical pair. This is a ball and socket joint. Okay? This can be moved. So you see the motion of my hand. So I am placing my hand over here. So you see the motion of my hand. You see the motion of my hand. Getting my point, beta? Getting my point. So you will find this spherical pair asked a number of times. Is asked at a number of time. ठीक है? बहुत बार पूछा गया है. It is asked number of times to us. ठीक है? It is asked the number of time to us. Why is it so? Because when we read something like ball, we get to understand, we get to imagine that it is rolling pair because ball is there saying. So you see in our body we have joined like this. I have taken the image from the net. So this is what we call our ball and socket joint. So if you see in this figure, so you can have a 3-dimension rotation. You can have a 3-dimension rotation as I have been showing you from my hand. Now, is it fine or not, beta? Is it fine or not? Is it fine or not? Boliye, is it fine or not? It is there in our body. It is there in our body, right? It is there in our body. Okay? It is there in our body. So the ball and socket joint. God made us in our body. भगवान ने भी हमारी बॉडी में लगा रखा है. Getting my point, बेटा? Getting my point. Now, so when some link is having 3-dimension motion with respect to the other one, so if I ask you what kind of a contact you can see here, so again the surface contact, and what other examples of it? So car mirror. So if you imagine the motion of car mirror, so you will see that it is rotating in 3-dimension in there, right? It is having 3-dimensional rotation. Similarly, if you see pen stand, so what pen stand I am talking about? Sir, I put my pen in box. No, that is not the pen stand I am talking about. So if you visited any government office lately, अगर आप कभी किसी पुराने गवर्नमेंट ऑफिस में गए होंगे, so there used to have a golden color pen normally used by the officers. So it was like this somewhat. कुछ ऐसा होता था. ये इस तरीके का पेन स्टैंड होता था. एंड यहाँ पे बेटा एक गोल्डन कलर की पेन आप प्लेस करते थे. बहुत सुंदर पेन होती थी. वेरी ब्यूटीफुल. ऑफिसर्स लोग रखते थे भैया अपने वहाँ पे. आज भी देखने को मिलती है, लेकिन उतनी नहीं मिलती है. So in this pen stand, if you observe, अगर आपने कभी देखा हो, so in this kind of a pen stand, what happens? This green color, I tried to make the pen here. Although it is golden. So what happens? So this pen stand, so this pen can have this type of rotation. This, it can move like this. That is why it is called. So if pen stand they are asking you, so you can say it is an example of spherical pair. Is it understood or not? I hope it is understood to all of you. Now we have now completed the classification of kinematic pairs on the basis of their relative motion, right? Relative motion के basis पे, on the basis of the relative motion, we just classified this kinematic pairs. ठीक है? Relative motion के basis पे बेटा हमने क्लासिफाई कर लिया है, रिलेटिव मोशन के बेसिस पे माय डियर हमने क्लासिफाई कर लिया है हमारी काइनेमेटिक्स पेयर्स को। तो जो लिंक बेटा जो किस प्रकार का मोशन कर रहा है, कैसा मोशन है, उसके अकॉर्डिंगली हम डिसाइड कर सकते हैं कि भैया हमारा किस प्रकार का पेयर फॉर्म हो रहा है और कौन सा पेयर किस टाइप का कांटेक्ट बनाएगा, व्हाट काइंड ऑफ कांटेक्ट इज फॉर्म बिटवीन द लिंक्स इज आल्सो देयर। ओके, now the other way of classification is, as we understood, the other way of classification is according to the type of contact. The other type of classification is according to the type of contact. Getting my point, beta? According to the type of contact. So in this, we can classify it in two ways. One is lower pair. Okay. So lower pair is what? So how can we classify according to the type of contact? Now, can anybody please tell me what is this lower pair? And the other way is higher pair. Higher pair. So can you tell me what is this lower pair and what is this higher pair? Can you tell me what is this lower pair and what is this higher pair? Can you tell me? Can you tell me what is this lower pair and what is this higher pair? Anyone? Anyone? Lower pair and higher pair क्या है? Can you tell me बेटा? So when the links having surface contact, when they make surface contact, when they form surface contact, we call it a lower pair. And when they form line or point contact, we call it higher pair. So for example, in the previous classification, turning pair, sliding pair, so all the pairs except rolling pair, falls in this category. Rolling pair fall in this category of higher pair. Other than that, all the pairs we have seen according to the type of relative motion. So according to the type of relative motion, all the other pairs all the other pairs that were formed and been seen and we have seen, they all form lower pair because they have surface contact. Now, is it okay or not? And now I want to give you one note also here. So one higher pair. So it is a common knowledge that one higher pair is equivalent to two lower pairs. One higher pair is equivalent to two lower pairs. Okay, so please remember this. एक higher pair जो होता है वो दो lower pair के बराबर होता है. Sir, we have read it. How it is possible, sir? How it is possible? Now I want to ask you something. So we got this. So let's say. So we have this, and let's say we have this. Let's relate or let's compare these two mechanisms or these two systems. Okay, so these are famous systems, no? ये हमारे famous systems हैं. These are famous systems, right? These are somewhat famous system. One is engine, or one is single slider crank mechanism. Other is cam and follower, right, my dear? Now, if I give input here, the output we get will be in the form of reciprocation here also. Output we get will be in the form of reciprocation here also. Now, can we say this? can we say this, that kinematically, now can we say this kinematically both are doing the same thing? Kinematically both are doing the same thing. Can we say so or not? Please answer me. Can we say so or not? Please answer me, my dear. Please answer me. Can we say something like that or not? Please, can you answer me, my dear? Can you answer me that? Can you answer me that? Please answer me, the live students. Kinematically, they are doing the same thing because their input and output motion is same. If I talk about the motion, if I say about the motion is same. The input motion to output motion, both motions are same only, right? Both motions are same only. Right or wrong? Right or wrong, my dear? Right or wrong? Agreed or not? Please answer. Those who are live can answer to me. Please answer me. Please answer me. Please answer me. Please answer me with that. Can you please answer me? So definitely, sir, we can see the input is in the form of rotation and the output is in the form of, the input is in the form of rotation and output certainly is in the form of, 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 output certainly is in the form of what? Output certainly is in the form of reciprocation. So kinematically they are same, right? Kinematically they are same. Now, if we start counting the links, so what we can say, if we start counting the links, so this is 1, this is link 2, this is the piston link number 2, this is 3, this is 4, and this is 1 only. We in the last session understood how we can judge the links. So the number of links here is 4. Number of links here is 4. Now, how many pairs I can see from here? Now, how many pairs I can see from here? Now, how many pairs I can see from here? How many pairs I can see from here? Can you tell me? How many pairs I can see from here? So, I can see, my dear. I can see, my dear. So, I have a pin joint here. I have a pin joint here. I have a pin joint here and I have a sliding pair. Now please remember not to forget counting the sliding pair because these pins are very much visible. Right, so when we see this figure rightly we are seeing the pins. Okay, so turning pairs are very well visible, but sliding pairs I have seen in my experience that students usually forget to count. So now if I say how many pairs are there in this, so we got 3 turning pairs and we got 1 sliding pair. So all are the lower pairs. So we can say the number of lower pairs is 4. Now is it fine or not? Can you tell me please? You need to reply, beta. You need to reply to me. Is it fine or not? Is it fine or not? Please answer. Is it fine or not? Please answer to me. So I hope you are getting my point. I hope you are getting my point, right? I hope you are getting my point. So we have 4 lower pairs here. We have the 4 lower pairs. And now if I count the joint in this, so this fixed link, fixed, this is 2, this is 3. We counted the link yesterday in the previous session also. We counted the link of it in the previous session also. We counted the link in the previous session also, right? We counted the link in the previous session also. ठीक है? ठीक है? ठीक है? Okay. So we counted the link in the previous session also. So we got 3 links there. We got 3 links there. We got 3 links there. Getting my point? We got 3 links there. Okay. Now what are the joints in there? What are the joints in there? So we can see a turning pair here. We can see a sliding pair here. So what is the lower pairs? What is the number of lower pairs? So 1 turning, 1 is sliding, that is two lower pairs. Now if I observe in here, so we have a higher pair. This is what we call as a higher pair, isn't it, beta? This is what we call as a higher pair, right or wrong? This is what we call as a higher pair, right or wrong? This is what we call as a higher pair, right or wrong, my friend? Right or wrong? Right or wrong? So yes, sir, this is what we can say as a higher pair. This is what we can say as a higher pair, right? This is what we can say as a higher pair. This is what we can say as a higher pair, right? ये एक higher pair है बेटा. This is what we can say as a higher pair. Yes or no, beta? This is what we can call an higher pair. Now the things are very much visible to you. Now the things are very much visible to you, aren't they? Now things are very much visible to you. Are they or aren't they? Things are very much visible to you now. How? How, sir, if they are visible? Now what you can say from there, beta, what you can say from there, my dear, that's since kinematically they are doing the same thing. Now things are in front of you only, beta. चीजें पूरी की पूरी अब आपके सामने हैं. Now things are very much in front of you, my dear. How, sir, they are in front of us? Because sir, you see, in this input is rotation, output is reciprocation, input is rotation, output is reciprocation. Now kinematically we can say they both of the systems are doing the same thing. Kinematically we can say both of the systems are doing the same things, right? Both of the systems are doing the same thing. Okay. Now the things which is in front of us, so we can say here in this first figure, for changing rotation to reciprocation, we require 4 lower pairs. But in the second orientation, in the second system, for changing the rotation to reciprocation, we require only 2 lower pair and 1 higher pair. Because we can see a higher pair there, so we require 2 lower pairs and 1 higher pair. We require 2 lower pairs and 1 higher pair, right? Now can we say very, very suitably, can we say very with much of the confidence, now sir, the use of, sir, for kinematically changing rotation into reciprocation means kinematically doing the same output, kinematically for the same input to the same output, kinematically for the same input and the same output, 2 lower pairs are replaced by 1 higher pair. Please tell me yes or no. Is it okay or not? Please answer me that. Is it okay to you guys or not? See here, please see here. So rotation to reciprocation, in this mechanism 1, we are changing rotation to reciprocation. In mechanism 2 also we are changing rotation to reciprocation. So in mechanism 1 we were using 4 links, 4 lower pairs. In mechanism this we are using 3 links, 2 lower pairs and 1 higher pair. So definitely 1 higher pair for same kinematic input to output conversion. For same kinematic input to output conversion, 1 higher pair is doing the work of 2 lower pairs. So I hope this statement is also justified to you. So beta, we will call this session end at this point. ठीक है, हमने in this session, my dear, beta, we have seen the types of relative motion, the examples of the types of relative motion, right? We have seen what is kinematic pair, how we can classify the kinematic pair, right? What is the surface contact, where is the point contact, where is the line contact, what were the examples of it. Okay, and lastly, we have established this important note that 1 higher pair is equivalent to 2 lower pairs. So I hope beta this session is understood to you. Please comment, subscribe, like and share the test book. Okay, please share करिए बेटा, अपने friends पे share करिए. Please share in your social platform. Please go and visit the website also. Please go and install the app also. Okay. So because we are doing all this, beta, this is only free for you. So many subjects are running on the channel. So definitely please subscribe it. It is going to be very, very helpful for you. So with this note, thank you very much. And in the next session, we'll be talking about the degree of freedom. Okay. So the next session is going to be very, very important. Okay. So do not miss. Do not miss. So we'll see you in the next session. For the notifications of the session, please subscribe the channel. You will get the notification of whenever the new video will come. Alright, so thank you very much. With this, I'll be ending this session. Thanks a lot.